Okay, today I'm going to get you to where you will derive the quadratic formula. Okay, you've used the quadratic formula in the past, but you're going to figure out essentially where it comes from. Okay, but before I do that, I'm just going to review some basic skills here. All right. First of all, this is all stuff you've done in Algebra 2. If I asked you to factor this trinomial, x squared minus 6x plus 9, what would the two factors be? X minus 3, x minus 3, which means you could write it as x minus 3 quantity squared, right? Everybody with me on that? Okay. So this trinomial right here is called a perfect square trinomial because it can be written as a quantity squared or something squared. Just like 49 is a perfect square because 7 squared is 49. 81 is a perfect square because 9 squared is 81. This trinomial is a perfect square because x minus 3 quantity squared is equal to that trinomial. Okay? What's the next one?
X plus 7.
X plus 7 quantity squared. Good. Okay? Alright. So now here's my next question. Could you tell me what number would need to go here so that this trinomial is a perfect square? It is 25, yes. Okay, it is 25. Now, here's a little trick. Okay, if you look back up here, what's half of negative 6?
3.
Negative 3. Square that. What's negative 3 times negative 3? 9. What's half of 14?
7.
Squared.
49.
Okay, what's half of negative 10? Negative 5 squared. 25. So it would factor to x minus 5 quantity squared. Right? What's this last one going to have to be?
81.
81, because then if you were to factor it, x plus 9 quantity squared, right? Okay? So, all four of these trinomials are perfect squares. Okay? And in order for it to be a perfect square, the constant, okay, is exactly half of this value squared. So half of 14, which is 7, squared is 49. Half of this is 5 squared is 25, and so on. Okay? That's the only way that they are perfect squared, because obviously the two numbers would have to multiply to this and add to this. So it'd have to be half of that b value. Okay? Alright, so kind of keep that in mind. Another review topic, this is from Algebra 2, is solving a quadratic equation by completing the square. You may not have chosen to use this method a lot. I know you were taught how to do it, but you may not have chosen how to, or to do this one. You probably would have just chosen the quadratic formula. Okay? So let me go through just a quick review and stop me if you have questions. Okay? If somebody told me to solve this quadratic equation by completing the square, the first thing I would do is actually divide everything by 2. Okay? Because everything is divisible by 2 and it gets rid of that coefficient. So I'm going to divide everything by 2. The process of completing the square is essentially making it so you have a perfect square trinomial on one side of the equal sign. Right now I do not have a perfect square trinomial. Okay? This negative 20 back here is not the correct number. If that negative 20 was a different number, then I would have a perfect square trinomial on the left side, but right now it's not. So I'm actually going to move that negative 20 over to the other side. In order to move a negative 20, I would just add 20 to both sides. Okay? And I'll talk about the plus points here in a second. So all I've done is I've moved the 20 over to the other side. Okay? Now, this is an equation. It's like a balance. I have something is equal to something. Okay? What number would you like to put here so I have a perfect square trinomial on the left side? 36. So, if I want to, I could just put my own plus 36 on the left side of the equal sign. But if you do it to the left side, you got to do it to the right side. So now we have on the left side, a perfect square trinomial. Let's write it as a quantity squared. What is the left side of the equal sign? What would it factor to?
X plus 6 quantity squared.
X plus 6 quantity squared. So x plus 6, or x plus 6 quantity squared. And I'm going to go ahead and add those two values together to get my 56. Now the tough work is done. It's pretty easy to solve for x. What do you think I would do to both sides right now? Square root, because that gets rid of the squared. So I square root this side, that leaves me with just x plus 6. When I square root the 56, don't forget your plus minus sign, and then the square root of 56 would simplify to 2 radical 14. Right? And the last thing, subtract 6 from both sides. So x equals a negative 6 plus or minus 2 radical 14. There are your solutions. Look through all those steps. I know that's probably a really quick review. You have seen it before. You might not have done it enough to kind of have it memorized. But is there anything that I did that you don't quite follow so I can clear up? Because I need you to be able to follow this in order to derive the quadratic formula. Is there any step you'd like me to show a little more work on or talk a little bit more about? Okay. So last year, you guys were told that in order to solve a quadratic equation, you could just use this formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay? And so you did. You used it. In Algebra 2, you just use that quadratic formula. In advanced math, I want to show you why that formula works, or why we can use it. Okay? We're going to take the exact same process here, but we're not going to use numbers. Okay? So which is basically making or showing you how it's true for every number there is. Okay? So if I have a quadratic formula that looks like this. So I have ax squared plus bx's and then plus the constant c equals 0. I'm going to take this equation right here and I'm going to solve for x. And I'm going to use the exact same method that I used over here. Okay? My goal is to get x by itself. It's kind of hard to get x by itself when you don't know what a, b, and c are. You can't really factor it. You can't combine like terms and get x by itself that way. So we got to use this completing the square method to solve for x. So if you look back over at the problem we did that had numbers in it, the first thing we did was do what to both, or do what to everything? We divided by 2. So what do you think we're going to do? Divide by a. Okay, I'm going to divide everything by a. That would be x squared plus b over a x plus c over a equals 0. So now again, I'm trying to get a perfect square on the left side. But I don't have a perfect square right now. That c over a value is not necessarily half of this squared. So I don't think that c over a is what I want there. So I'm going to move it over to the other side. It's the wrong number. Just like back in here, this negative 20 was the wrong number, so I moved it over to the other side. And now I'm going to figure out what number I actually want to put there in order to make the left side be a perfect square. So remember, to come up with this number that makes it a perfect square, I cut this value in half and then square it. Okay? So here's probably the trickiest part. I cut this number in half and then I square it. So I have to cut this in half. Does anybody know what half of b over a is? If you think of this, 1/2 of means multiply in math. B over a. What's 1/2 of b over a? B over 2a. Okay? B over 2a. So half of b over a would be b over 2a, but then I need to square that. And when you square a fraction, you just square the top and you square the bottom. So if I square b over 2a, what do I get? B squared over, careful, 4a squared. B squared over 4a squared. B squared over 4a squared. B times b is b squared, 2a times 2a is 4a squared. Now, on the left side, I have a perfect square. Okay? Just like on this problem, I had a perfect square. It's x plus half of that value times itself. Okay? So in this case, my left side could be factored to what? X plus b over 2a. Quantity squared. X plus b over 2a times x plus b over 2a would equal this perfect square trinomial that we have right above there. And on the right side, I'm going to go ahead and combine those or add those together. But because they're fractions, I would need common denominators. So what would I need to do to that first fraction so it has the same denominator as the second one? 4a. Multiply it by 4a. So I'm going to multiply it by 4a on the top. I'm going to multiply it by 4a on the bottom. And I will get, that would be a negative 4ac plus the b squared that I already had all over 4a squared. Because as soon as I multiply it by 4a over 4a, then both of my denominators are 4a squared. So I can write it as one single fraction, all over 4a squared. My numerators are different, they're not like terms, but I have a negative c times 4a, which would be a negative 4ac, plus the b squared. And I can just add those together all over my common denominator. Yes, no? Doing okay? Alright. Should start to see some resemblances of the quadratic formula start to show here. We're getting closer. Now what are we going to do? We're trying to solve for x. Square root both sides, okay? So when I square root here, the squared goes away. So x plus b over 2a. And when I square root a fraction, what do I have to do? Square root top and bottom. If I square root the top, that's not a perfect square. That's not very nice. So I'm just going to leave it as plus or minus the square root. I'm going to go ahead and switch the order around. Instead of negative 4ac plus b squared, I'm going to write b squared minus 4ac because I know where I'm trying to go with this. When I square root the bottom, do I get something a little bit nicer? 2a. And lastly, to solve for x, I need to subtract b over 2a. So I'll get x equals a negative b over 2a plus minus the square root of b squared minus 4ac all over 2a, which you'll notice they have the same denominator, so I could write them as one fraction, negative b plus or minus the square root b squared minus 4ac all over 2a we have just derived the quadratic formula. So now we know that this formula will work for any real numbers A, B, and C in a quadratic formula.